Hey everybody, welcome back to Jim's Garage. This is probably the video you've been waiting for, especially if you've been following my MS01 adventures. In this video, we're going to have a look at setting up the Thunderbolt 4 ring network using just Thunderbolt 4 cables, no adapters. I'll also show you how I've created my cluster between my three MS01 nodes. Each one of those is running Proxmox and is connected via 10 gig to my new USW aggregation switch. I'll also cover that. So let's quickly jump into my new hardware. That's the Unifi aggregation switch. I bought this because if you remember in my previous network diagram, I wanted to make use of the two 10 gig SFP plus ports on each of the MS01s, but my current switch didn't have enough ports to do that. Remember, I'm doing the backhaul ring network, which is going to be responsible for things like Ceph, I'll do that in a later video, and also things like VM migration, etc., backups and things. That's all going to take place on the Thunderbolt 4. However, for traditional access into my cluster, so things like this PC I'm recording it on, or all my Wi-Fi devices, etc., those are still going to access it over RJ45 through the switch into an SFP. So that's why I need that SFP connection. So I was pleasantly surprised to see that Unifi actually sell the aggregation switch for about £230. It's still a bit of money, but it's far cheaper than I expected, and actually, surprisingly, it's the same price as some of the Microtic switches, and it comes with the benefit of I already have a Unifi setup with my Unifi controller, so I could just adopt that and have that single pane of glass for management, which makes life so much easier. The actual process for implementing that into my stack was quite simple. So if you remember before, I had a Unifi switch 48 PoE Pro. That was basically doing all of the heavy lifting. Now what I'm doing is I've inserted the Unifi switch aggregation in front of that switch, and basically it's the sandwich between my firewall and the PoE Pro. So all of the heavy lifting takes place on that USW aggregation. That gives everything on there 10 gigabit. And it also then has a direct connection into my Pro PoE switch, which still gives access on those devices at 10 gigabit speeds maximum, albeit shared. Now, I haven't set up the lag yet, that'll come in a later video, as per the diagram I discussed previously, but I just wanted to get everything migrated first and get the switch up and running before I went down another rabbit hole. So the actual process of setting that up was quite simple. I simply mirrored the existing port on my Pro PoE. That's the one that was going to the firewall. I mirrored that onto my new aggregation switch. That then enabled me to simply pull out the SFP cable and stick it into the new switch, and the controller was able to find it. If you do get into any troubles, just remember that the default LAN is where it's going to pick up its IP address. It's usually a 1.1 or a 0.1, both /24s, and make sure that it has access to reach your controller for adoption. If it doesn't automatically detect, you can do the set inform method where you SSH into the device. You can check the IP of the device on its screen, which is a really handy feature, and then set the inform, and fingers crossed, as long as you've got the firewalls in place, it should show up within your controller. Then you're off to the races and you just configure it like you would a regular switch. So let's get on to the bit you've all been waiting for. Now, as I said in a previous video, I haven't worked this out. I'm using a great guide that's been online for a while and has many contributors. I will link that below and I'll be referencing it throughout this video. But basically what we're doing here is we are turning the Thunderbolt 4 into essentially a network adapter, because networking is part of the Thunderbolt 4 stack, USB 4, whatever you want to call it nowadays. And we're then setting that to be usable within Proxmox, and we're also setting up a fabric network using those devices so that things like it becomes hot pluggable and it won't change during reboots, IPs stay static, etc. The final bit of the puzzle is then within Proxmox itself. We need to change the network it uses for all of its kind of back-end processes, those migrations, those backups, etc. And I'll show you how to do that in the end of the video. So to get this started, I was a little bit apprehensive. I knew that the MS01 supported the full USB 4 Thunderbolt 4 stack because I'd read lots of reviews on it, and I had some confidence that this would work. So I went out and I purchased some Cable Matters Thunderbolt 4 certified cables. I'll link those below. I haven't had any problems with these. I chose the shortest length that I could just to make cable management easier, and I can't wait to actually take it off my test bench and put it onto my rack sometime soon with some actual decent cable management. I have been trying to improve the rack because it is an absolute nightmare, so I look forward to sharing that with you. So let's have a look at the instructions. Let's dive into Proxmox. let's get this thing up and running. Do note that you don't have to have your Proxmox cluster joined at the moment. You can do that in a subsequent step. So here we have my new Proxmox cluster. As I've mentioned, not all of the things are up and running with respect to my network diagram, but the bulk of things are complete. I've migrated all of my VMs and my K3s cluster over to these machines. I'm reaping the benefits of the speed, performance and power savings, and that was kind of the key thing that I wanted to do first. So as you can see on here, I've got 3 nodes, Abaddon, Dawn and Sanguinius, yep, 40k nerd, and all of the devices are on here for networking. Now this network setup is replicated on all 3. If I click on them, you can see that here. And what are we looking for in here? Well, the key things here really are this LO and the LO6, and also at the top here, EN05, EN06 Ethernet. Now, how did we get here and what does this mean? Well, to get here, I followed this guide here, which we'll come back into in a moment. So what does that mean? Well, it means I can hop into the shell now, and I'm able to ping one of my other machines. So I can do a ping FC00 : and let's do, which one are we on? Sanguinius, so 81. If I hit return, you can see now it's pinging it over that Thunderbolt 4. And we're getting about 0.2 milliseconds, which is pretty awesome. And if I now hop on to a different node, remember we were just on the Sanguinius, if we go on to Abaddon, if I now run a iPerf 3, so setting up a server, that's now listening on port 5201. If I now hop back onto my Sanguinius server, let's see what the speeds are like over this network. Now, I've quickly had to log into my old friend Putty for this one, just because as I changed in here from the shell, it actually cancels the server, so it doesn't keep it running. There's probably a flag I can put it on to make it persistent, but I just want to show this in real time. So if we do an iPerf 3-C, and this is using IPv6 for now, I haven't actually got the IPv4 working at the moment. That's something I'm going to work on, but IPv6 should be fine for this. Again, it's only an internally routable network between these nodes. And I've set it to bidirectional. Let's see what happens when we run this command. So you can see it's connected and it's transferring 22.8, 22.7, 22.6. Again, coming back 22, 23. And you can see that I've got 22.4 gigabits per second bidirectional. There's quite a few retries in there compared to, say, a standard NIC, but remember that a retry is not a failure. It still did manage to do it, and then it carried on. Now, if we don't do a bidirectional, we might get a little bit more speed out of it. Let's just see what happens there. Looks like we're getting 22.8, 23, 23.6. Seems to be slightly more performant, which is kind of what you'd expect, but not significantly different. In fact, yeah, only got 0.4, but it is slightly faster. But anyway, digressing, you can see that this is consistently 2 times faster at least than the existing 10 gigabit modules that are on there via the X710. And the only thing you really need to do to take advantage of this is to buy that USB Thunderbolt 4 cable. So let's dive into how I got here. Now, hopping back over onto the GitHub by Saito, there's actually a gist here for lots of different things. So you'll see on this page that the person here is using 3 NUCs, and those are good because they, again, made by Intel, the old ones, they fully specify the full Thunderbolt 4 specification. So I'm only going to focus on a few of the items here. I'm going to skip over the hardware and the Proxmox install. You can check out my videos. There's millions of those on how to install Proxmox. We're going to start actually on point 2. We're then going to do the Open Fabric routing, and then I'm going to duck out of this. In later videos, we can have a look at things like the Ceph and the high availability, but I'm going to deviate slightly from that because there's a few tweaks I want for my setup. But again, do note, this is a really handy guide online for you, so do check it out. So let's begin by looking at the mesh networking setup. Now, it's pretty straightforward. The first thing you need to do is to install LLPD. You don't technically need that, as you can read on the screen, but it's really handy for working out which Ethernet adapter, which Thunderbolt 4 adapter you're actually referring to when you plug in and out a cable. So you'll actually run this in a moment. and you'll be pulling the cable in and out, and you'll actually see some printouts for which PCIe device it's registered to on the machine, and you'll need that later on because we're going to pass it through in the network interfaces section. So the other thing you're going to need to do here is to add the Thunderbolt and the Thunderbolt network kernel modules. Those are required because you want to load Thunderbolt, right? And you want to load the Thunderbolt network adapter. Now, previously, I'm talking probably late last year, this wasn't in a good spot. Linux had kind of dropped Thunderbolt networking support just because it's kind of a bit antiquated now. It's not going to go any further. But thanks to Saito and the guys on here, that's actually been fixed in recent kernel versions. I'm running kernel 6.8 on Proxmox 8.2. And I think there's a minimum kernel version, here, 6.2. So you need 6.2 or higher to make this work. And I think 6.2 is Proxmox version 8. So you're going to need Proxmox version 8. But this should work on basically anything that's kind of Debian based. So you don't just have to do this on Proxmox. So if I go into my modules, as we see on the right here, you can see that I've loaded the kernel modules for PCIe pass-through, because on these devices at the moment, I'm passing through the iGPU to my Kubernetes cluster and a few Docker VMs, and I'm also passing through the X710 to my OpenSense firewall for the performance increase, but also because of the SFP module for my ONT that I'm using that cannot be used in a bridge, doesn't work. But crucially here, you'll see that I've got Thunderbolt and Thunderbolt Net at the bottom. So you need to add those, save it, and close it. Next, you'll see on the left-hand side that we've got to stipulate some new network interfaces. And those are the ones that I showed you earlier on my networking tab on my Proxmox node. You saw that we had EN05 and EN06. So if you look in my network setup, in here, you'll see that I've got this part over here, and you can see that here on the screen. Now, it looks slightly different to this here, and I suspect that's because as I've copied this over and I've saved it and I've performed a reboot, it might actually rejig a few of these things. So I think maybe the allow hot plug command has now become automatically puts it up. I might be wrong. Happy to be corrected in the comments below, but this is working for me. So once you've added that, and importantly here is this bit, you need to remove any Thunderbolt sections in here that you might see. I think on one of the nodes, and it's bizarre I didn't see it on all, I actually had the Thunderbolt show up here. So one of the names was actually Thunderbolt. You need to delete those and replace with these. Now that you've done that, we actually need to now identify the ports that we want to use. Now, I'm going to be doing this obviously on my MSO1, but the same principle will apply to any of your devices that have a dual Thunderbolt 4 port. So what you need to do here is run the UDE VADM monitor. So if I copy that and I'll paste it into here, when I run that, it's now watching for changes on the device. Now look what happens when I reach over and I pull out one of the Thunderbolt 4 ports from the Abaddon node. As I pulled that out, you saw a load of stuff come up. Now, the critical thing here that we need is this address here, this 000D.2 in my case. This will be different for every device you plug into. What's great is it's actually the same for all three of my MSO1s, i.e. the left-hand port is the same on every single one, and so is the right-hand port, but that's not necessarily guaranteed. And I'm going to plug this back in now just so it gets working, but when I plug this back in, it's also going to bring up the same details, but for a plugin, not a disconnect. And because, as I've just demonstrated in the previous, and this is already working, these are hot pluggable, so I should be able to plug it back in and it will be up and running. So plugging back in. Hopefully that screen will update. Yeah, there we go. We saw the screen update, and that's back in now and should be up and running and should be working again. As you'll see, it's still got that 00D.2, and it's actually automatically assigned it down here to EN05, which is what we're going to be setting up in the next step. Now let me just cancel that, because the crucial bit is we go over to the left here and we use these IDs to actually assign the network interface to the specific port on the device. Now, what you need to do here is you need to create these two files. So you're creating these .link files for both of the ports. So this process I've just showed over here on the right, you're going to need to do that for your first interface and then repeat the process for your second interface. The crucial bit here is that you update the PCI address here. So in my case, it's exactly the same. It's that D.2, and it was actually, again, D.3. Perhaps that's the default for how Intel set it out if you're using like a vanilla chipset or something like that. I don't know. I do know that on my Ugreen NAS, my 480T Plus, it was different. Now, unfortunately, I couldn't get that to always be stable and survive reboots, etc. There's probably a way, so if there is, do let me know. But as I said, crucially, you need to make sure you get the IDs from over here, pop them into here, and then you assign it to a network name. Now, if you look closely on here, you'll see that the match, so this is basically within this file, it's matching this device over here by its PCI path. If those for whatever reason aren't the same, or you can't obtain that, sometimes there's subpathing within PCI, you can actually use different paths, or sorry, not a different path, you can actually use a different criteria. So you can actually base it on things like the physical MAC address, the state of the device, etc. So do note that there are other ways to match it to a device if the PCI path for whatever reason isn't working. Hopefully it will be as simple as I'm showing on here. Once we've done that, we need to make sure that this can survive a reboot. Obviously it'd be really frustrating if it didn't, and part of the reason we want this HA. Now, the way to do that again is really straightforward. This one is just a copy and paste job. So we're creating some new rules, and we're basically just creating two scripts to make sure that this reboots on a network plug. As you can see from the script here, it's possibly a bug that this doesn't happen. I haven't actually tested it without. If you're brave enough, you can maybe skip this step. Do let me know. Feels like it might be an old hang-up with older distributions of Debian. Like I said, some of this stuff was borderline deprecated and it's now had a new lease of life. But I went ahead and I created these files just in case, and I'm happy to say that my nodes, my cluster, is behaving as expected, i.e. it will survive a reboot, it will come back up, you can still do those pings, etc. So create those files, and then we can move down. The important thing here is to make sure that both these files we've just created, these shell scripts, are executable so that it can be run each time on a boot, and that should make sure that the interfaces come up every single time. Once you've done that, you need to reboot the machine. So make sure each machine you do this to, once you've created those scripts, added the devices, make sure you reboot for them to take effect, and you can also test it. Next, we're getting on to the IP connectivity. Now, as it says on here, it's for IPv4 and IPv6. I haven't actually managed to get the IPv4 working yet, albeit I haven't put too much effort into it because the IPv6 is working and it's fine for me, but it is something that I want to go through and find out why isn't this working. So now we get on to the interesting parts. And if you remember from my previous part, if you go onto networks, you'll see here that we've got the auto LO and auto LO6, those are both here, and we've also got that EN05 and EN06 at the top here. You'll also see that they are auto start, and that's the bit where we did it earlier with the hot plugging and the auto ability. But let's have a look what we need to do here. So we need to go back into the network interfaces, and within the network interfaces we need to add this section here. Now, as you can see, I've added that over on this bit. And the critical part here is that you change the X here. You see the X? So on mine, I've got IPs of 81, 82, and 83 for my respective nodes. So for every single one, you need to make sure that you use a separate IP address. These, remember, are a /32, so these are going to be static. There's no DHCP going on here. This is a simple point-to-point and kind of a ring network. So add those devices, and when you do that, it should end up looking like this. Again, do make sure, don't copy and paste this every single time. Be certain to change that IP address. And once you've done that, you're not quite done yet. You need to add the following line to the bottom. As you can see, I've added that at the bottom of my interfaces file. What's that doing? Well, the clue's in the title. FRR, that's the fabric that we're going to set up in a moment as a new service. So this is what sits on top of this network that we're building, and that's the fabric network that we're going to create using these interfaces. So enact this for each node, and then we're ready to move on to the next step. So the next step is we actually need to enable things like IP forwarding. So to do that, we need to hop into the etc sysctl conf. So this looks like this on my machine. The bit that you need to scroll down, and it's this part here. So you need to uncomment and make sure that, in my case using nano in the shell, that's white, but whatever it is you're using, just make sure that those are enabled. You're going to need to save that and likely reboot for that to take effect. So add them, reboot, and then you're on to the next step. So the next step is that free range routing, that FRR service, which if we have a look up here, it's this one here that we referenced. So what we need to do here is to install, so an apt install FRR. You're going to need to do this process for every single node in your new cluster. Once that's installed, we need to edit its configuration. As you can see highlighted on the left in blue, we need to go into the FRR daemons, and in here we need to change one setting. So it's that fabric here, that fabric daemon. We need to enable that yes, so that the fabric daemon is running and we can use the fabric network. Once you've added that and saved it, you need to restart the service with that restart command here. Once you've done that, you then need to go into the service and configure it. So to do that, we need to run vt ysh. And now we've entered the FRR routing binary, and we need to use the configure command. Now I'm going to show my running config, so show running config, because I already have this set up. And there you can see, in reference, this part down here. So simply all you need to do, if you're doing this for the first time, is to type in config, and then you copy and paste all of this in. Make sure you have the exclamation mark on the bottom line. Typically you might have to also hit return to get a white space at the bottom. Then you want to type end to actually quit out of that and apply. It's not the most elegant interface, but that's how I did it and how it works. And once you've done that, you need to then save it by running the write memory command. Once you've written it to the memory, you can do that show config command that I just showed up here, and hopefully it will look exactly like what you put into that machine. One thing you need to be certain of is that you did change this here, that fabric ID. As you'll notice on the left, similarly to before, there's an X there. You need to substitute that with a value for your machines. I replicated what I did for the IPs. So for example, this one's 81, so I called this one 1. The other one was 82, so I used 2, 3. You get the idea. Just make sure that they're unique and you remember them, and it probably makes sense to map it somehow to the IP address. Now, if that went well, you should be able to now exit out of it. If you did make an error, I simply went through that process again to fix it, albeit it says on here that you can basically edit this config file here. I didn't need to do that. Like I say, I just used the same process as before. And now, once you've done that, hopefully you'll be able to run the following command. That's the vt-sys -c, and then you can show the open fabric topology. So you'll want to do this command once you've set up everything so that there's something to see. Don't worry if you run it earlier, it's not going to break anything, it's just showing what's actually going on. So if I now run this command on my machine where this is all configured, you'll see that I've got the parent, which is this one. This is Abaddon. This one actually has the IPv4 address, which I set to 10 and then 81/32, but it doesn't show the other machines. And that's the bit I was talking about where I can't see IPv4. If you look at the example over on the left here, you can actually see that this is picking up all of those IPv4 addresses on the other machines. I do want to fix that, find out what's going on, but in terms of actual operation, I've chosen the IPv6 route, and as you can see on here, I've got 81, 82 down here, and then 83 in the middle. And that's how I've been able to create that network ring so that I can see all of these devices. Once you're at this stage, congratulations. everything is up and running. You should be able to do some pinging between the nodes to verify that they're up and running, and you could download, install iPerf and test some of that throughput to make sure that you're getting similar speeds to I am, test the cables, etc. You can try plugging it in, pulling it out, etc. You can reboot your nodes to make sure that it comes back up. But hopefully now you've got a Thunderbolt 4 network ring that's running at 2.5 gigabytes per second, and you can take full advantage of all of that blistering speed with a simple cable between the nodes. Now, to take advantage of that further, like I said, the core reason for doing this is we want faster migration, replication, etc. And ultimately, in the end, I want to run my Ceph on this. I'm not going to cover that in this video. That'll be another video. To do that, we want to head over into Proxmox. And you actually want to go to Data Center. Now, when you're in Data Center, you need to go to the options, and you'll actually see that there's migration settings here. So you want to click Edit, and then you want to choose the network you just created. So in here, you'll see that traditional VMBR0, that virtual bridge, which is typically the Ethernet port or whatever the first connection on your machine is into Proxmox when you install it. But you'll see this one here. And that's the one that I've selected to set up my network for my migration settings. Once you've set that, and I also set it to be insecure for a minor performance bump, you don't have to do that, but remember this is an isolated network just between those three nodes. Now, once you have that in place, you should be able to do some cool stuff. So over here on my Sanguinius node, I've got a Sophos XG that I've been playing around with, and if I want to migrate that machine, I can click on Migrate. And then if I want to send it from, say, Sanguinius to Abaddon, I can click on Abaddon and I can click Migrate. So let's see how quickly that goes across. Here you can see it's doing at 1.8 gigabytes per second, 1.8 gigabytes per second. So we're hovering around that 20 gigabits, which is double the speed of our normal network. So those X710s, they're great, but they're nowhere near as fast as doing it this way. And here you can see that I copied 32 gigabytes in 20 seconds, which is pretty awesome. And so the final piece of the puzzle is to set up now the Proxmox node, so the cluster itself. So if you've been following this video so far, you've got the ring network set up between these three discrete devices, but you won't have this interface I have here, whereby all of the nodes are part of a cluster. Thankfully, the way to get things into a cluster is pretty brain dead. You simply need to head into your data center, and instead of options where we were previously, we need to click on cluster. Now, here you can see that I've got my cluster up and running. Again, that's all running over that network, that fast network like you saw. And you need to click on the Create Cluster button. When you click Create Cluster, that's going to do some magic in the background on that node that you're working on. It's going to set up things like the CoroSync and get that ready. And then once that's completed, you get this handy button here, this join information. So when you click on that, you get this here. Now, this is basically the IP address. So remember, this is now the IP address over my X710. So this is going through my 10 gigabit to get that up and running. Later you can change that to use this link here. It's got a fingerprint and then basically the access key to join it, so it can join securely and the nodes speak to one another securely. You want to make sure that when you're doing things like data migration, that all of that traffic is encrypted on your network. So you simply copy this information. You will head into your respective nodes. So at this point, you've probably got, say, 3 tabs open. 1 tab for Abaddon, 1 for Dawn, 1 for Sanguinius. And you'll go into Data Center, you'll go to Cluster, and you'll click Join Cluster. When you click Join Cluster, you'll paste in this join information, and you'll just click Next. And literally, it's that simple. Once that's completed, you'll then get this cool interface where you see all 3 of your nodes down the left-hand side, and you'll be able to go to, say, your options and just double check that that is selected for your fast Thunderbolt 4 ring. So thanks for watching, everybody, and hopefully now you've got everything you need to be able to set up that Thunderbolt 4 ring, take advantage of all those blistering fast speeds for only the expense of a Thunderbolt 4 cable. I've also showed you how to join your Proxmox nodes together. If you need more information on that or want to see an actual walkthrough as opposed to me just talking about the steps I did, I can do that, but genuinely it's as simple as creating the cluster, copying the information onto the other node and clicking join. In a video in the near future, I'm going to show you how to set up Ceph, taking advantage of the ring network we just created. The beauty here is that we get advantage of all those fast speeds of 2.5 gigabytes per second, which should be more than enough for Ceph to be happy. It does complain on things like a gigabit connection. It mandates a minimum of 10 gig from what I've read in the documentation. Once we've got that, it will mean that we can then use the Ceph storage for all of our VMs. That will give us replication across all the nodes, and things like migration and high availability on virtual machines will make that possible. So a VM, if it collapses, it will be able to spin up on a new machine because that machine also has a copy of its local data. Now, do bear in mind that you can't necessarily do that with all virtual machines, especially if you're doing things like hardware pass-through. That's because to pass through the PCI device, it actually maps some of the memory on that node, and that isn't replicated to the other node. That memory might be in use, for example. Anyway, I'm getting on to the next video already. Let's park it there. Thank you very much for watching. Please let me know if you've got any comments or queries. Pop those down below. I've put the links down there as well as the hardware I used to set up the cluster, those cables. And as always, if you've liked this video, hit the thumbs up, hit the sub, and I'll see you on the next one. Take care, everybody.